Now, some list view columns contain numeric values, but without proper formatting, they can be difficult to interpret at a glance. In this lesson, we're going to explore math operations and how we can apply currency formatting to ensure financial values are displayed clearly. We'll also look at how percentage calculations can help provide better context in list views. Now, before we start applying these transformations, let's first expose the cost column. To do that, we're going to head into Settings, click Objects and Fields, navigate to the Equipment Maintenance History object, and then select Default Columns. We can now add the cost column from the dropdown to add it to the list view and then drag to where we want to display it. Right now, the cost column is just a number, but since it represents a dollar amount, let's format it accordingly. We can do this by adding a currency symbol and ensuring values always have two decimal places. So we do this by adding the $sign, our double curly brace, our field name of cost, then adding the pipe, the word number, and then in brackets decimals equals 2, which will show two decimal places. This ensures that even whole numbers appear correctly with the cents displayed rather than just $100, for example. Now that we've formatted the cost column, let's take things a step further and apply math operations. Skedulo's templating system supports a range of math operations, including addition, subtraction, multiplication, and division. Let's take a look at a real-world example, applying sales tax to our cost field. Instead of hard-coding a percentage, we can store the sales tax rate in a separate field and reference it dynamically. Let's say we have a field called sales tax rate. We can calculate the total cost including tax rate using this formula. Now, the tax rate can be adjusted dynamically without needing to modify the column template. For example, if different regions have different tax rates, we can use an if statement to apply the correct percentage, where we check each region and then apply a different tax value based on the region assigned on the record. With this approach, the total cost is automatically adjusted based on the region name. Now, of course, we could take this a step even further, creating a custom field on the region object to store the sales tax percentage and reference that field in our formula as well. But just to demonstrate the point, I'm using a simplified example here. Let's look at another useful transformation, displaying percentages. Let's say we want to show how the cost compares to a standard benchmark of $80, which represents the typical cost of repair or replacement. We can calculate this by using our double curly braces, cost divided by 80, multiplied by 100, close our curly braces, and add the percentage symbol at the end. This will output a percentage value, making it easier to compare costs at a glance. Equally, instead of using a fixed number, we could also store the benchmark value in a separate field and reference it dynamically, such as cost divided by benchmark cost multiplied by 100 and add our percentage sign. This means the comparison adjusts dynamically based on the stored benchmark value. Now, while math operations can be useful, there are some important limitations to keep in mind. These formatting changes only affect how values appear. They don't modify the underlying data. Calculated values cannot be filtered or sorted since they don't exist in the database. If you need to filter and sort on calculations, they should really be stored in specific fields where automation can be used to calculate the value and then store it in the database. So by applying math operations, currency formatting, and percentage calculations, we make numeric data more readable, comparable, and actionable in list views. I'll see you in the next lesson.